Now we're going to look at AMU5L6 trig functions of any angles. What we've been looking at so far is just the trig functions of positive angles. And we're going to start looking at angles on the coordinate plane. If this was the x and y axis, and if I have, as your guided notes tell you, if theta is a standard angle, so that means the vertex is in the center, and its radius is r, and there's a point px on this line. Well, I could drop down an imaginary line straight down, form a right angle. Now I have a right triangle, and this terminal side of my angle becomes a hypotenuse. So I could use the Pythagorean theorem to find the length of this. So this will be handy if you just have a point on a plane. You're going to be able to find the length of that radius, but I need the lengths of the two sides so I can use the Pythagorean theorem. Now we're just looking at a general setting, so instead of two numbers for a point, we have x and y. Well, you can translate x and y to be the lengths of your two sides. The length of this side down here is what? Well, it's the distance from the x-axis. And what tells you that distance is the x-coordinate. So the length of this side is x. Now if I had the point 5, 7, then that would be 5. So you see how this is going to translate to numbers later on. Alright, if the length of this side is x, then the length of this side is y. So using the Pythagorean theorem, I could say, well, x squared plus y squared is equal to, and instead of h for the hypotenuse, we're going to use r squared. Okay? Now, let's take a look at our 6 trig functions, and I've written down the definitions that we've been using. The opposite over hypotenuse, adjacent over hypotenuse. So if you want to jot those down on your guided notes, but we're fixing to expand that, we're going to get another definition. So, and we're going to use this figure over here. Well, now I'm looking at it from the viewpoint of this angle. So my sine of theta, and this is going to be theta for my definitions, I want the side opposite over the hypotenuse. So what is that? Well, it's y over r. Now remember, y is in your ordered pair. So we're going to be able to fill these out with just an ordered pair and a radius in a minute. That's where we're headed with this. Okay, so now from cosine theta, the side adjacent is x over the hypotenuse, which is r. And then for the tangent, it's going to be the side opposite, which is y, over the side adjacent, which is x. And then since these are reciprocal functions, you don't have to even refer to your graph anymore. You can just flip these. So this is going to be r over y, and this is going to be r over x, and this is going to be x over y. Okay? So like I'm saying, if you just have an ordered pair, you can figure out the trig function for that particular angle. Okay? So let's have a look at a problem. Okay, for number 1, we're given a point P at 9, negative 12, and we want to find all 6 trig functions. Now you can sketch it out if you want to, but we really don't need to. Our new definitions, which are over here, all I need to fill in all 6 of them is an x, a y, and an r. Okay, since this is an ordered pair, what do I know? I know that x is equal to 9, and I know that y is equal to negative 12. Now, what's r? Well, I can find r by using the Pythagorean theorem. So I'm going to have 9 squared plus negative 12 squared equals r squared. So this is going to be 81 plus 144 equals r squared. So I'm going to have r squared is equal to 225. And then I will take the square root of each side, and this is going to be r is equal to 15. Okay? So let me put that in here. Now, all I'm going to do is fill in all of my functions and simplify if necessary. So for sine, I want y over r, okay? My y is -12, and my r is 15. Now these will both reduce by 3, so that's going to be 4/5. Okay? Now cosine is x over r. So I have 9 over 15. Both of these reduced by 3. So I've got 3/5. All right, tangent is y over x. So I'm going to put -12 over x, which is 9, and then that's going to reduce by 3, so I'm going to have 4/3, -4/3. Okay, now all of these are just reciprocals, so I can just flip them. My sine reciprocal of that is -5/4. Secant, the reciprocal of that is 5/3. And cotangent, the reciprocal of that is -3/4. And that's all. Okay, for number 2, we have a point at -6, -2, and we want to find all 6 trig functions. Now, just like on the other one, we already have x and y. So if x, I don't want to run out of room, if x is -6, y is -2, and I need to find r, Pythagorean theorem. So I'm going to have -6 squared plus -2 squared is equal to r squared. So this is going to be 36 plus 4 is r squared. So this is 40 equals r squared. Take the square root of each side. So r is square root of 40, but that does need to be reduced. What's a perfect square that will go into 40? 4 times 10. So when you simplify it, you have 2 square root of 10. So our r is now 2 square root of 10. Okay? Now let's get some room to work. Okay, my sine of theta is y over r. So when I look over here, I've got -2 over 2 square root of 10. And I'm coming over here because we're going to have to simplify it, and I wanted to walk through it with you. All right, first of all, 2 over 2 cancels out. So now what I actually have is -1 over square root of 10. You cannot have a radical in your denominator, so we're going to multiply that times square root of 10. Whatever you do to the bottom, you have to do to the top. Now, -1 times square root of 10 is negative square root of 10. Square root of 10 times square root of 10 is actually square root of 100, which is 10. So our sine, simplified form, is going to be negative square root of 10 over 10. Okay? So now, let's work on cosine. All right, my cosine of theta is x over r. So that's going to be -6 over r, which is 2 square root of 10. And I need to simplify, okay? 6 and 2 reduce down and leave me 3 on the top. So what I have now is -3 over the square root of, and that's not a 6, that's a 10. All right, now rationalize this denominator by multiplying by square root of 10. Whatever you do to the bottom, you have to do to the top. All right, square root -3, square root 10 on the top. And once again, square root of 10 times square root of 10 is square root of 100, which is 10. And none of this will reduce down. So we're just going to put -3 square root of 10 over 10. Okay. And technically, your negative signs are just in front of the whole thing. They're not either numerator or denominator. Okay, so next we're going to do tangent. Well, tangent is y over x. So if I take my y and I put it over my x, well, the negatives cancel out, so I have 1/3. So tangent of theta is 1/3. Okay? Now let's work on the others. Because of the radical in the numerator, instead of flipping on this time, we're going to go back to the beginning, because whenever you have a radical in your numerator on these, if you go back to the beginning, you may not have to rationalize, and this is what I mean. Cosecant is r over y, so that is 2 square root of 10 over y, which is negative 2. So the 2's cancel out. You have this negative to contend with, so it's going to be negative square root of 10. But you did not have to rationalize. Okay? Then secant of theta is, let me get some room, r over x. So now I have 2 square root of 10 over negative 6. So these two cancel out, and I have negative square root of 10 over 3. So that's negative square root of 10 over 3. And then last but not least, yep, my cotangent theta. Now, since tangent was just a fraction, I can just flip it. I don't have to come back over here. So that's going to be 3 over 1, which is just 3. So take it step by step on your simplifying, and don't let that overwhelm you, okay? Because this is really not that hard. Okay, the next thing we're going to look at is the signs of each angle according to quadrant, because it varies. And I'm going to show you, you could figure this out every time, but it takes a few steps. So if you can memorize some little gadget real quick, this is going to help you out. First, I want to show you how this came about. If you look at quadrant 1, all of the ordered pairs in quadrant 1 are made up of positive, positive, right? And all of the ordered pairs correspond to x and y, right? The other letter that we have, the r, the radius, r is always positive. R is always positive because that's your radius. So the only thing we have to worry about the sign of is the x and y. So let's take a look at, since everything is positive in quadrant 1, we're going to label it all, because we're going to say everything is positive for quadrant 1. All right, now quadrant 2 with a negative x and a positive y. If I came over here and I marked all the x's and y's with negatives and positives, and y is positive and y is positive and x is negative. Now, if you have a fraction where they're both positive, what is the fraction? It's positive. If you have a fraction where one is negative, it's negative. Here's one that's negative. All right, what about this one? It's all positive. This one's negative, and that one is negative. So which functions are positive in quadrant 2? Only your sine and your cosecant. And remember, those are reciprocal functions. So that's why they're both. But anyway, we're going to write up here sine and cosecant. All right. Now, we can do the same for the other functions. Let's do one more. In quadrant 3, x and y are both negative. So if I came over here and I put negatives where all the y's and the x's are, let's see what that would do. Okay, now let's go back and see. If my y is negative here, then my whole fraction is negative. If x is negative here, the whole thing is negative. Now here where I have negative over negative, that turns it to positive. Okay, and then the reciprocals are going to match. I'm going to have a negative and a positive. Okay, so which functions would be positive over here in quadrant 3? That's going to be your tangent and your cotangent. Okay, now if I did the same thing for a positive x and a negative y, what I would find out is that's going to be cosine, and its reciprocal function secant. Okay, so let's make a little chart of this. In quadrant 1, everything is positive. In quadrant 2, now this is a chart of the positive things. In quadrant 2, the positives are sine and cosecant. In quadrant 3, we have tangent and cotangent. And in quadrant 4, we have cosine and secant. Now there's a little phrase you can use to remember this, and that phrase is all students take calculus. Here's all students take calculus. So it's not perfect, but it does give you the first letter, and then you have to remember that the other function is that reciprocal function, okay? But this will help you. All students take calculus, and it goes counterclockwise. All students take calculus. Once you remember that, you can tell which ones are going to be positive, and that's going to be a big time saver because you're not going to try to figure out did you go left and down or left and up, okay? So you'll see. Okay, let's consider numbers 3 through 6, and they want us to, given the information, they want us to tell which quadrant or quadrants this scenario could be in, all right? Cosine greater than 0 means where could cosine be positive? Well, everything can be positive in quadrant 1, and cosine is positive in quadrant 4. So that's all you got to do. All right, now let's look at tangent. Where is tangent negative? So you got to think. Where it's negative is where it's not positive. So cross off where it's positive. It's positive in quadrants 1 and 3, so it must be negative in quadrants 2 and 4. Okay? All right, now where is secant negative? Well, let's find where it's positive. It's positive in quadrant 1 and it's positive in quadrant 4, so 2 and 3 are where it's negative. Okay, now here we've got a combination. So we want to find out where could sine be negative and cotangent be positive. So let's do them one at a time and then we'll combine it. So where all is sine negative? Well, where it's not positive. So where is it positive? It's positive in quadrants 1 and 2, so it's going to be negative in quadrants 3 and 4. All right, now where is cotangent positive? Well, it's positive in 1 and 3. So which quadrant is for both of them? Both of them have a 3. So your combined answer is quadrant 3. Okay, sine will be negative and cotangent will be positive. Now let's get a handle on numbers. Remember, we only have 3 that we're worried about, x and y and r. Okay, sine was y over r. So there's 2 of them. My y is 8 and my r is 17. All right, how can I find x? Good old Pythagorean theorem. So we're going to have x squared is equal to, x squared plus 8 squared is equal to 17 squared. So we have x squared plus 64 is equal to 17 squared is 289. Sorry. All right, subtract 64 from each side and we get x squared is equal to 225. And then when you take the square root of each side, x is equal to 15. Okay? Now, we are good to go. You have x, y, and r. You know the signs already, so we're just going to plug these in. All right? The cosine formula is x over r, so we're going to have 15 over 17. The tangent formula is y over x, so we're going to have 8 over 15. these three, if you remember, they're just reciprocals of the first three, so we can just flip the first three. All right, this is going to be 17 over 8, and this secant is going to be 17 over 15, and that cotangent is going to be 15 over 8. And that's all. So it kind of, you do so much work on the front end and so much thought, but then once you get that done, it just all falls into place, and it's kind of a letdown actually. Okay, for number 8, we have an angle whose cotangent is -4, and the secant is greater than 0. So that means the secant is positive. So first, let's figure out which quadrant it's in. Now, where is cotangent negative? Now remember, our little thing here tells us what is positive. So if it's negative, it's wherever it's not positive. So it's not here and not there. So the first one checks the boxes in quadrants 2 and 4. Okay, now where is secant positive? Well, it's positive in quadrant 1 and in quadrant 4. So this is going to be located in quadrant 4. Now in quadrant 4, which of our things are negative? Let's go ahead and mark those. Well, everything except the cosine and the secant. So this is positive and this is positive. So we're going to have negative and negative and negative and negative. Okay, now we don't have to worry about our signs. We have that down. Okay, what we need to do is get what x equals, what y equals, and let me put this up at the top so we don't run out of room for me to work. So if I want to know what is x, what is y, and what is r. Okay? Now in the other problem, I could get 2 of my numbers from here, but since this is a whole number, I only have one number. Well, I know you're saying you can put 4 over 1. The problem is now the whole thing is negative, and I don't know which number is negative. They can't both be negative, because if it's -4 over -1, then that would be positive. So they're not both negative. I need to know which one is negative. That's where this is going to come in handy. Now in quadrant 4, what do you know about your x and your y? Well, x is to the right, so x is positive and your y is negative. So when we come down here, this is actually x and y. Well, if y is negative, that means 1 is negative. Okay, so that's where this comes in handy. So now, as I write my numbers, I've got x equals 4. I've got y equals -1. All right, I need an r. Now remember, no matter what, r is going to be positive. So to figure this out, I'm going to use Pythagorean theorem. I'm going to have 4 squared plus -1 squared is equal to r squared. So this is 16 plus 1 is equal to r squared. 17 is equal to r squared. Take the square root of each, so r is square root of 17. Okay, so that was a lot of work, but now we're just ready to plug in what we have. All right, we already know that the cotangent is -4. So let's come over here and put -4. All right, we know that tangent is the reciprocal of that, so I can put -1, 4. All right, now for sine. The definition of sine is y over r. So I'm going to have y, which is -1, over r, which is square root of 17. And like I said, we already know the sign, so we don't have to worry about that when we're reducing here or rationalizing. So I'm going to multiply by square root of 17 over square root of 17. So that gets me square root of 17 over 17. So that is sine. Negative square root of 17 over 17. All right, now for cosine, what's my definition? X over r. So my x is 4, my r is square root of 17. I'm going to rationalize. Square root of 17 over square root of 17. So now I have 4 square root of 17 over 17. So let me squeeze this in here. 4 square root of 17 over 17. Okay. Since I have radicals in my numerator, if I just try to flip them for these two reciprocals, it's going to have to be rationalized again. So I'm going to go back to my original now. What is the definition for cosecant? Well, that's r over y this time. So when I put square root of 17 over 1, remember I've already got my sign, this way I don't have to rationalize it. So that's just going to be negative square root of 17. And the definition for secant is r over x. So I'm going to have square root of 17 over 4. So square root of 17 over 4. Okay, let's try one more. Okay, let's look at number 9. We have cosecant theta is equal to negative square root of 5 over 2. And cosine theta is less than 0. That means it's negative. So first let's find our quadrant. Well, for cosecant to be negative, let's find the quadrants where it's not positive. Cosecant is positive in 1 and 2. So it's negative in 3 and 4. All right, now where is cosine negative? Well, it's positive in 1 and 4, so it's negative in 2 and 3. So since this is it, our function is in quadrant 3. Our angle is in quadrant 3. Okay? Now in quadrant 3, tangent and cotangent are positive. So let's go ahead and mark those, and then we can just put negative for all the others. So we know our signs already. Now let's find our x, our y, and our r. Now cosecant is r over y. So my r is square root of 5, and my y is 2. So how do I find my x? Well, we're going to use the Pythagorean theorem. So I have x squared plus 2 squared is equal to square root of 5 squared. X squared plus 4 is equal to 5. Subtract 4 from each side. So x squared is equal to 1. Take the square root, and x is equal to 1. All right? Now, let's start filling in. So for sine, and we probably will have to rationalize some of these, so let me get some workspace. All right? Sine is y over r, so that's 2 over square root of 5, and that's going to have to be rationalized. So I'm going to multiply square root of 5 over square root of 5. So I'm going to have 2 square root of 5 over 5, and it is negative. So 2 square root of 5, negative 2 square root of 5 over 5. Okay? Now for cosine. All right, the definition of cosine is x over r. So I've got 1 over square root of 5, which will need to be rationalized. Multiply both of them by square root of 5. So now I'm going to have square root of 5 over 5, and it is negative. All right, now for tangent. The definition for tangent is y over x. So I'm going to take y over x. 2 over 1 is just 2. All right, now for cosecant, I already have that. That was given to me. So I've got square root of 5, negative square root of 5 over 2. Okay? For secant, and since I've got radicals, I'm not going to try to flip it. I'm going to go back to my beginning. That way I won't have to rationalize. So my secant is r over x. Well, r is square root of 5. X is 1. So my secant is just negative square root of 5. And my last one, my cotangent, is x over y. So I'm going to go to x over y. That's just going to be 1/2. And there's your 6 functions with the correct signs.